Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Welcome back, everyone. I am absolutely thrilled to have you here for today's explainer. We're going to be breaking down a couple of truly fundamental concepts in software testing: black box testing and equivalence partitioning. Now, I know that might sound like a mouthful, kind of highly technical, right? But stick with me, because it actually relies on incredibly elegant, beautifully straightforward logic. So I want to start off by asking you to think about a puzzle. Imagine you're handed this incredibly complex machine, and your boss says you need to guarantee with absolute certainty that it works flawlessly. But, oh, there's a catch. And it's a huge one. You literally are not allowed to open it up. No way. You can't look at the gears, you can't inspect the wiring, and the internal logic is completely 100% invisible to you. How on earth do you test a system like that? Honestly, it sounds impossible, doesn't it? But this is exactly the puzzle that software testers solve every single day. Okay, let's dive into this. Section 1. Inside the black box, navigating invisible paths. And that brings us to our foundational definition: black box testing. Just like the name implies, the software is treated as a literal black box. The internal mechanics, those thousands upon thousands of lines of code, the complex routing paths, all of it is entirely unknown and invisible to the tester. You're basically navigating invisible paths. Instead of focusing on how the software does its job behind the scenes, you're focusing purely on the output generated by a specific input. You put something into the box and you watch what comes out. That is the entire game right there. Section 2. The user's perspective. Judging by results. And this brilliantly illustrates the stark contrast at the heart of this methodology. On one side, we've got the fact that the tester has absolutely zero knowledge of the internal code. That entire side is completely hidden from us. But on the other side, we have this immense power, an input-output driven approach. We get to control exactly what goes in, and we precisely measure what comes out. By deliberately blinding ourselves to the code, we're actually evaluating the software purely on its actual tangible behavior. The primary advantage here is that this method perfectly mimics how real, everyday human beings are actually going to interact with the software out in the wild. Think about it. A customer using an app, they don't care about the backend database structure or some fancy algorithmic efficiency. They just care if the button actually works when they click it. Black box testing is done entirely from that user's perspective, placing a laser focus on functionality and usability. It really forces the system to prove itself where it actually counts. And what makes this methodology just incredibly powerful is its sheer versatility. You don't just use this once and forget it. Black box testing can be applied at literally every single level of system testing. We're talking unit testing for a tiny, isolated little function, integration testing for making sure multiple components play nice together, final acceptance testing right before you launch the whole shebang to the public, or even security testing, probing for vulnerabilities. You can always apply this user-centric mindset. Section 3. Equivalence Partitioning Explained. The ultimate shortcut. Because here is the great dilemma every software tester faces. Let's say a text field accepts any number from 1 to 1,000. Do you really sit there and type in 1, then 2, then 3, all the way up to 1,000? Absolutely not. Nobody has the time or the budget for that. So we need a clever hack, right? We need a way to radically reduce our test cases down to a manageable size, but, and this is key, without compromising our confidence that the system is fully, completely covered. Enter equivalence partitioning, often called ECP for short. This is the absolute sanity-saving solution for testers who are staring down infinite input possibilities. Instead of testing every single number one by one, ECP is a black box technique that divides all the possible input data into groups, or partitions of equivalent data. By doing this, we dramatically shrink the number of test cases we actually need to run. So, the crucial point is the underlying logic here. Like, why are we allowed to just group things together and skip testing every single number? Well, it all comes down to this key principle. The system is programmed to treat all cases within an equivalence class exactly the same way. It's like a giant sorting machine. If you test just one item in that group and it behaves correctly, you can confidently assume that all the other items in that group are going to behave correctly too. If one passes, they all pass. If one fails, they all fail. Let's move to and see how this builds. Section 4. The age field example. Theory and practice. Okay, think about a standard digital form you've probably filled out a dozen times online. Let's say you're signing up for a news streaming service, and there's an age field. The business rules state that this specific service is strictly for adults, but it stops at a certain demographic. So the system is explicitly programmed to only accept ages from 18 up to 60. Anything else should immediately trigger an error. Here's how an expert tester actually uses equivalence partitioning to conquer this exact field. Instead of banging our heads against the wall testing every single number from 1 to 100, we divide the data into exactly 3 partitions. First up, we have our invalid partition 1 for literally any age under 18. We pick a single test value from that bucket, let's say 15. We input 15 into our black box, and boom, we expect it to be rejected. Next, we have our valid partition, which represents that accepted range of 18 to 60. We pick one number right in the sweet spot. Let's use 30. We input 30, and the box should happily accept it. Finally, we have invalid partition 2 for any value over 60. We plug in 65, and again, the box should spit it right out and reject it as invalid.
Now, what's really interesting about this slide is the number 3. Just 3. By really understanding equivalence partitioning, we didn't need to test 100 different ages. We didn't even need to test 50. We needed exactly 3 specific, carefully chosen test values to confidently prove that the entire age field logic is functioning perfectly. 3 tests to give us complete coverage. That, my friends, is the incredible, game-changing efficiency of black box testing.
It completely changes how you look at software, doesn't it? Seriously, the next time you're booking a flight, signing up for an app, or interacting with literally any digital form, I want you to stop and ask yourself, as I type this information in, how are my inputs being partitioned inside that black box? What invisible boundaries did some smart tester draw to ensure this system worked flawlessly for me? Thank you so much for joining me for this explainer. Keep questioning the systems around you, and as always, keep learning.